Hey, boys and girls, we're going to discuss natural selection again. So y'all might want to look away. Oh, two people bailed already, so we're good. Okay, it's dropping, losing focus, losing interest.
Somebody disliked the discussion long before it was.
Was that you, Danny?
No, I don't. Look, I don't think I've ever disliked any of your videos ever.
Maybe it's me.
I don't. I want your channel to grow and be healthy. So
I suspect it was Ox because he said something about the beach.
He said he was going to the beach. He said, "This is boring. I'm going to the beach." I don't know why people would find theories and things like that boring, but theories and causality and all of that. So, so you like David Lewis, right? On causality.
He's a brilliant philosopher. I almost disagree with everything he says. He's a modal realist. He's a naturalist. But he's a brilliant philosopher.
But I mean, on his causality stuff.
I don't know anything specific to his view of causality. I'm guessing he's a Humean.
He's got possible world semantics. Hume kind of like just touched on causality, but David Lewis kind of expanded it. But another one is Judea Pearl, and he uses the Bayesian and probabilistic notion of causality. And if you really want to look into causality, I think Judea Pearl's got a bunch of videos online, except it's really hard to understand him sometimes because he's really an interesting, laid-back guy with a hell of an accent. But he's pretty interesting. But if you're really interested in causality, it's a very rich, deep field.
Do you know David Lewis's modal? Do you know what modal realism is?
Not really. No.
He thinks all hypotheticals are actual. Okay. So, there's a world in which you and I are married, and he thinks that actually exists.
I reject any philosophy that says there's a world where you and I are married.
Then you're not. Because people are going to say that's possible, but not actual. But David Lewis says that every possible world is just as real as the actual world.
Yeah. Yeah. When it comes to modal logic, I like to use, I actually like to depict truth tables as being possible worlds. Every line in the truth table.
Yeah, I think it's fine.
Yeah. Mm-hmm. Yeah. Which is the only way to make sense out of truth tables. Because truth tables, like if you have, two variables, anything can happen, right? True, false, whatever. So you got to look at every possible.
Each row is going to represent a
possible world.
Right? Yeah, right. That's fine. Yeah, I think that makes sense.
Yeah, and the other thing about truth tables is truth tables makes you limit your description of all worlds, so now you know the universal, the scope of what you're talking about. So that kind of narrows it down. Like you can't talk about C if your truth table only has A and B, which would probably piss some people off because they want possible worlds to be more intuitive. But anyway, so your claims on natural selection are pretty profound and pretty.
That's the thing. I don't think they are. I think that they're not profound in the sense that let's say I'm right and you're wrong. I don't think anything changes. I think we can still talk about natural selection as acting and causing and being a mechanism, but even though it's not true, it's very useful to talk about it in that way. I think that what the scientists do, they make models, they go into the field, they make predictions. I think all of that is good. I just don't think they get any of that from the theory or from this thing called natural selection.
Okay, so here you're describing what you say Fodor thinks. Okay, what Fodor thinks that a theory. Oh, okay, let's look at one of the claims that you made.
Okay.
I said Danny has claimed that we should call Evo Bio a historical science. What would you mean by historical science? So what would a theory be in a historical science?
So let me just take a historical example. We know that Napoleon lost at the Battle of Waterloo. Right. We want to give an explanation for that. Okay. We give, I think, a pretty good explanation for why he lost, right? We could talk about the mud and, maybe Napoleon had lost his mind for, I don't know, we could, The historians give a good explanation for that. So in the same way, we're here. You know, there we have a huge diversified biosphere.
Right.
Okay. So why? Right. And the evolutionary biologist answers that question in the same way.
Okay, so let's see. So there's no empirical tests we could do on whether Napoleon lost the battle.
Absolutely, there is.
Well, we could test mud and soldiers.
Well,
right?
we can rely on testimonies. We can rely on archaeological evidence. We can rely on the weather at the time. Like we can look back and look at our weathering models. Like why did Napoleon lose? He tried to invade Russia. Lost his mind during trying to invade Russia during the winter. Right. We know that history about there being a harsh winter during the time he invaded. So. No, of course there's empirical data that's utilized in history.
So what would be the difference between historical science and a theory science? What is the other science? What is the alternative?
Where the predictions are sort of coming from. Okay, so suppose you and I have gotten a lot of arguments. We've yelled at each other. We've insulted each other. Someone might predict the same thing will happen here. Okay, They used the history, right, to make predictions. Now, they did not use a theory of StreamYard and a theory of YouTube and a theory of Danny and a theory of how Danny interact. It's basically bottom up. We go from the particulars to a prediction rather than a theory to a prediction.
Okay, so bottom up instead of top down. Okay. So bottom up is historical, where we pick all the particulars and make some.
We have a lot of experiences with how organisms interact with their environments, and so biologists have their wealth of experiences is multiplied by 1 million. Right? They do a lot of work to understand animal anatomy and physiology. So genes, genetics, and ecological variables. Abiotic factors. Biotic factors, and then they create a narrative, and then they draw on the narrative to make predictions. What happens if we throw a grizzly bear in the Arctic? Well, we know things about grizzly bears. We know things about the Arctic. We can make predictions from that. We don't get it from a theory of selection, though.
So we don't want to scare you, but Digital Hammurabi's in the chat, and he has some very tough questions.
He's my monster. Frankenstein's monster was less scary than Digital Hammurabi.
And we do know that Gur is a disappointment to everybody, but okay. So the thing is, though, okay, you're saying that evil by all of evolution, okay, evolutionary theory, the theory of evolution, is a historical science. And then when I didn't want to, I wanted to be sure, and you said, evil bio is essentially natural history. Okay.
Yeah, so and essentially for a reason, right? Because there are things that biologists understand that are not reducible to just historical predictions. For instance, they might rely on a physics equation. They might rely on chemical laws and gas laws to make certain predictions about genes and so there might be on the molecular level, there may not be simply drawing from their history, the history of DNA and its causal tendency and amongst past events, right? But essentially, the question for evolutionary biologists, why is there this diversified biosphere? Why is it that we're seeing these fossils? Why is it that we see these sorts of organisms? And why are they the way they are given these ecologies? That is the essence of evolutionary biology, is to ask that question.
Okay. That in itself is a claim. But you're not talking about natural selection. You're talking about the entire theory of evolution.
Yeah, I'm talking about evolutionary biology in general. Mm-hmm.
Okay. So the theory of evolution includes natural selection, embryology, genetics, epigenetics, popgen, ecology, geology, biology, taxonomy, phylogeny. You understand the theory encompasses all of those things. You're saying that entire body is just natural history.
Yeah, you see, I think that when the word theory is being used in theory of evolution, I think that's the colloquial use. I don't think that's the scientific use. That's like, we have a theory about, slavery in the United States and how eventually dissipated, right? But I think that's a different sense of theory, the scientific use of theory, because I think the scientific use of theory is parasitic on laws, on these strict regularities. But I think that when we say there's a theory of evolution, where what we're saying is that here's our account of how this happened, right? Here's the account of the past, generally speaking, right?
Okay, yeah, we get some coffee grinding going on in the background. Can you hear that? Let's see. So here's what you say with digital notes. That what Fodor thinks that a theory of evolution is supposed to do is articulate principles between ecological variables and certain phenotypic traits, and the way they move to fixation across generations in the population. That's what they're supposed to do. Who says that? I mean, that's not anyone else's claim. That's Fodor's claim, right?
Yeah, this is from his book, almost straight word for word. The idea on Fodor. Yeah, you want to say something?
Okay, so this is what Fodor thinks.
This is what
evolution. This is what Fodor thinks evolution is supposed to do.
No, not evolution. A mechanism or theory of evolution.
Theory of evolution is supposed to. Okay, that's what Fodor thinks.
I can see why that's confusing. It says Fodor thinks that a theory of evolution. He's not saying Fodor thinks that the theory of evolution is this. He's saying that a theory. So a mechanism or theory of evolution is supposed to articulate such principles or causal tendencies.
Okay. So we have traits that we find in a population, and Fodor thinks that it's supposed to articulate principles between ecological variables and certain phenotypic traits. Okay, why doesn't embryology and ecology and geology do that? Why aren't there laws in that theory that basically give us some idea about how some of these things happen?
I have to understand your question.
Okay.
So ecology, to me, is so closely related to evolutionary theory. I will admit that they're not the same field of study, but
right.
So that's going to be a little bit harder to parse out, because I think that in terms of ecologies, what we're studying is maybe we might be studying behaviors that are not heritable, right? In ecology, I think evolution is very interested in this heritability. It's the study. I think evolution is about this kind of way of population thinking that is on a more macro scale in terms of multiple generations and traits moving across generations. Like, I think that's what it's interested. And of course, it starts with things like you need variation, right? So you have like a theory or an account of how mutations occur. And so that's kind of like almost the starting step, given that you need variation for evolution to occur.
Right.
But I think the more clear example is, let's use did you invoke geology or paleontology?
Yeah.
Okay.
Yeah.
So can you rephrase the question using that? What was it?
If I rephrase the question, okay.
Well, you can say the same question exactly. You don't have to rephrase it, just so I can internalize the question.
Well, geology is almost a subset of ecology. So geology and biology would be a subset of ecology. So ecological thinking, like ecological principles, would look at the entire energy of a system. Like you'd look at a cubic foot of Earth, right?
I see. So ecologists might study volcanoes and stuff like that. Is that what you're suggesting?
Well, the ecologists are going to study soil, okay. Like how soil came to be. And yeah, a long time in the past, they're going to have to figure out how volcanoes created the rocks that ended up in the soil. But ecologists are going to understand maybe you take a cubic foot or cubic yard of the forest, and half of the yard is above the ground, and the other half is below the ground. And you look at that entire system, and you look at it as a system, and it has energy going in and energy going out. So you can measure that. You can actually measure that, and you can make some predictions about what's going to happen inside of that system. So that's all ecology. And that's all a subset of evolution. That's where you would end up.
You think? Sorry, you said it was a subset.
Okay, before we get too far off the track, what I'm trying to say is a theory of evolution. When we talk about a theory of evolution, we are talking about a whole lot of sub theories, right? And sub studies. Like we're talking about natural selection is probably the key element of evolutionary theory. But then we have embryology, we have which is where you're going to get that connection between gene and phenotype, right? That's where you're going to go from gene to phenotype. So that's an important thing. It's embryology. So genetics and epigenetics is how we're going to study the different systems for natural selection. We're going to study diploid organisms, haploid organisms. We're going to, and each one is going to have its own model of natural selection. You understand, based on the genome. And genetics is going to, cover most of that. So population genetics is going to cover, it's going to overlap with natural selection a lot, and then it's going to tell you how basically genes vary in populations. Okay. Now, when I talk about a gene, what I'm talking about is a string of symbols, a string, right? So I have a string of symbols, and I'm calling some particular string of symbols, I'm calling that a trait. Okay, in genetics, that would be a trait. We're not talking about anything to do with having legs or arms or any of that stuff. That doesn't happen until you get to embryology. What I'm trying to explain to you here, Danny, is why, when you bring this subject up, why every scientist in a room loses his shit.
I mean, that's just a psychological. I mean, I may not know specifically, but I don't see what. I'm going to refrain.
Right, I think they lose their shit because there's like a miscommunication going on, between your world and their world. And I watched a group of them lose their shit on digital gnosis the other day, and I've seen it over and over again. But I mean, they do lose their shit, and there's Sober lost his shit with photo.
Yeah, he did. Towards the end, he started. That was pretty entertaining.
But anyway, so I mean, it happens a lot, and what I'm trying to get at is an understanding of the two different fields. I will say that, and I said this on a stream the other day, the one thing you have done for me is that you made me think about this in more depth than I ever would have thought about it.
Okay.
Had you not?
Me too. I mean, when I discovered Fodor's objection, I was already sympathetic to it because I was a creationist.
Right.
And noticed that, guess who are the most sympathetic advocates of Fodor's objection is a lot of ID theorists reviewed the book very well. And there were a few philosophers, almost none, no scientists that seemed to endorse the argument. But I will say that it's not just the disagreement's not just coming from scientists. Most philosophers think that Fodor was wrong. So it's not even just, it's not this, I would not say that it's this like break in communication between the philosophers and the biologists. It's actually just a break of communication between Fodor and everyone, including philosophers. Right. So I wouldn't be so quick to if you should be critical of philosophy, just be critical of me and Fodor and maybe like a handful of other people. I think most philosophers are on your side. So
yeah, I think when later on I'm going to broadcast a second talk I had with Dr. Nicholson, and I think the first thing he said is, "Who in the hell said that evolution is in the business of predicting?"
Well, natural selection is in the business of explaining.
Explaining, but not necessarily predicting. Okay,
yeah,
predicting.
You can make predictions and not talk about causality. Look, if you were to just meet someone and they were to cover their eye and you see a brown eye, okay, you could predict that the other eye is the same color, but you don't have to know why, the causal mechanism behind it at all. Okay?
Right.
So people, especially now we do know the causal mechanism, the unifying causal mechanism, such that I have the same color eye. But the point is that 3,000 years ago, they couldn't even begin to get close to that, such a mechanism. But they made predictions like that all the time, very useful predictions, right? But so the thing is that you suggested it earlier. This notion of probabilistic causation seems to crap all over that, because what ancient peoples, if they were to say, yeah, I predict that one eye is brown, I predict the other eye is brown, they are not suggesting a causal relation. Okay, so I'm fine with those sorts of predictions, right? But where Fodor and I have a problem is we're taking a step further from prediction. We're going as far as saying explanation. That's to us, we're hearing something like this eye explains why the other eye is the same color. No. Right? There's a mechanism. There's a black box here, right?
Yep.
Between creating a human being and having eye color, we don't know what's going on in between. But yeah, and that's I think that's more or less the concern.
Okay. So what Fodor thinks, the theory of evolution, articulate principles between ecological variables and certain phenotypic traits. Okay, that's covered under ecology and embryology. So I don't understand how that's a criticism of evolution.
This is not a criticism of evolution.
Okay, what Fodor thinks. Okay, what is it? What does this mean here? What Fodor thinks. Okay,
so look, he's basically saying this. If we're thinking about a theory of history, more human history, let's be more exact, then such a theory of human history is going to articulate the principles by which how humans interact with their environment. Okay. So given such and such environmental or ecological variable and these certain set of circumstances, we can do a ceteris paribus clause, all things being equal. So given such and such ecological variable, and given such and such kind of human being with a certain disposition, the human will behave in XYZ fashion. Okay. This is what the behaviorists tried to do. This is what the learning. You know what operant conditioning is?
Yeah.
It's kind of learning theory. Yeah. This is what they were trying to do. Okay. And then in comes, well, specifically to learning theory, in comes Chomsky. Chomsky craps all over Skinner and the behaviorist and the learning operant conditionist, or whatever you call them. And what Fodor thinks is that everyone accepts, everyone, a lot of people in the field, both learning theorists and philosophers alike, linguists, think that Chomsky's objection to learning theory, like the Skinnerian sense of learning theory, went through. It was a good objection. And what Fodor does in the first part of his book is say, hey, my objection is to natural selection mirrors Chomsky's objections. Okay, so you should accept, and I'm going to show you how it parallels. Fodor says that I'm going to show, and given that, you should accept my objection, right? Because it's just a mirror.
Okay, so we're going to have to understand, and I don't entirely understand.
Me either. We can ignore that section, but I'm just trying to say I forgot your original question. Okay. It linked to your original question.
Okay. What I'm trying.
What a theory. So what you asked, what is this notion of what it means to say that a theory of evolution should do X? Well, what a theory of learning or a theory of human history should do is articulate in the former case how humans with certain dispositions receive information in the environment. Okay, and the latter case is how human beings might interact with their environmental conditions, right?
Right.
And so in evolution is how an organism, right, their traits, their phenotypic traits. And look, I understand. I looked at very many definitions of natural selection that they oscillate between phenotypic traits and genotypic traits, or genotypic properties rather. And so I understand that some people might find certain phenotypic traits contentious. I don't think it matters. We can just use your notion of natural selection because it is used in the literature to kind of like take a step back from phenotypic traits, but insert genotypic traits. What a mechanism or theory of evolution is supposed to do is articulate the causal tendency between these traits, whether genotypic or phenotypic, and ecological variables.
Okay. Yeah, that's what you keep saying, and that's what you say Fodor says, and then are you implying that the theory of evolution fails to do that?
No. Maybe you are understanding me. I just want to make sure. What Fodor is not saying is that this is what the theory of evolution is, right? He's saying that this is an explanation, and evolution is supposed to do this. He's granting evolution, right? He's granting it, right?
Okay, these are your words. What Fodor thinks that a theory of evolution is supposed to do is articulate principles between ecological variables and certain phenotypic
What I'm
traits.
trying to say is that
I got to ask you a question about that. Is
Yeah.
Fodor saying that the theory of evolution fails at this or succeeds?
No. He's saying this. Look, maybe this might help. There's a difference between saying this, Speed, the theory of evolution versus a theory of evolution. Those are two different things, right? Evolution, if I say that evolution is the account of which explains biodiversity, then what we're saying is the theory of evolution, okay? But when I say that a theory of evolution is supposed to do X, we're talking about the explanations within evolution, right? That might be the four most common, something like genetic drift, gene flow, mutation, and natural selection. Those are theories or mechanisms that are in the theory of evolution.
Okay.
And then he's trying to say what those mechanisms are supposed to do, right? And this is what he's saying.
Okay, so what Fodor thinks is that a particular mechanism in the theory of evolution is supposed to articulate principles. Okay. Instead of the theory of evolution.
Is that how you originally interpreted it or no?
No, I thought you were talking about the theory of evolution.
Sorry, that wasn't clear.
Okay, so you're talking about sub-theories within the theory, right? You're talking about like parts of the theory which are not the theory itself. Those are constructs within the theory, theory. So you wouldn't want to call that a theory. You would want to call that a construct within the theory.
Well, it depends on who you talk to. If you look at Ernest Mayers, or Mayr, I think, and last name David, I think David Diamond, I think that's his name. If you look at Gould, right? They treat or they rather name natural selection as a theory. But I think that's a terminological dispute fundamentally. What it doesn't matter. I think if you were to tell Fodor, well, hey, look, there are a lot of biologists that don't treat natural selection as a theory per se, then he would just say, okay, well, you think it's explanatory. So my argument is still going to run.
Right, it's explanatory. Yeah. So natural selection is explanatory, but natural selection consists of what?
Well, it depends on who you're talking to. Fodor admits this in his discussion with Sober. He says that he asked a lot of biologists and they came up with different answers. But I have the exact quote of what let me get it, of what Fodor takes natural selection to be. And if you want me to quote it, I can. But it's more or less what I said earlier on your stream. The simplistic understanding of it for me is that, hey, there's allelic changes because of fitness or differential reproductive success, or something like that. So but Fodor says this exactly. This is how he characterizes natural selection, word for word. Okay.
Do you know what page it's on?
I wrote it down right here.
Okay. Well,
So I got it from a video. Okay. And his discussion with Sober. So he says, quote, and I'm going to read really slowly. Okay. Creatures are selected for their relative fitness of their phenotypic traits and their ecology. Phenotypic traits are selected for their role and causing increases of fitness according to the following principle. If in a certain ecology, creatures that have phenotypic trait T are more fit than creatures with T2, then all else being equal, creatures at T1 will be selected in preference to T2. That's his understanding. Now, I think that pretty much that's a Steelman compared to what some biology textbooks say. And what I mean by Steelman there is not just a good representation, it's a better representation of the literature.
And that's from the conversation with Sober?
Yep, very beginning. I think it's 4-minute mark, but I could be wrong.
Yeah.
4 or 9-minute mark.
I think I have a transcript of that. Anyway, okay. So, God, I've already forgotten it. I wish you could put it on the screen.
I can if you want. I can just take a quick picture of it.
Yeah, why don't you go ahead and do that?
Okay. This is gonna be a little weird. I'm gonna have to put my this on the. I have to take a picture of my. It's very easy. Just I'm gonna have to stuff this in your face for a second. Okay,
It's fine.
Take a picture of this. Make sure that the picture comes. I hope it's not in reverse, but I don't think it is.
I can make you full screen.
Okay, no. This is my computer. Don't worry about it. Okay, I'm gonna hide behind this.
Let's see here.
Oh, okay, let's see if this came up fine. Okay, this did okay. We'll just work with it right now.
Okay.
So allow me to share my screen in a second. Exporting this to downloads, save in a second. Okay, I've opened this, and now I'm about to share my screen. We're gonna share a window. Okay, do you see it? I cut off the last sentence. Oh no, I didn't. Okay, there it is.
Okay, photos. Okay, creatures are selected for the relative fitness of their phenotypic traits in the ecology. Phenotypic traits are selected for a role increased fitness according to the following principle of fitness.
And then the bottom says preference to.
Right. Okay. Okay, so that's not. Let me see here. I wonder if you said it was at the 4-minute mark. 4 minutes.
You're gonna have to listen to the first 10 minutes. I mean, I could find it for you later and email you. I had to listen to it like 7 times because I had to write it down.
Yeah, I think I have the transcript for that, but I'm not sure. Is this sober? And I wonder if I don't know. Anyway, can't find it. But okay, so I don't really see anything wrong, except that we're looking at a pretty abstract version of the entire theory, right? Now, if we bring that down and we say, okay, a trait is a gene, or bring it even more general, a trait is a sequence of characters. Basically, it's a string. Okay. So we're looking at a string in a population, and we're not just looking at one string, but we're looking at a whole lot of strings in a population. So that's one axis, right? So we're looking at the variations in this one particular string in an entire population. And then we look at the variations across a number of populations, right? There are almost law-like things where we can make a retrodiction. We can predict backwards, basically, the relatedness of these two things based on the number of things that remain the same within these strings. Okay. And that's where natural selection is really important, because what's going to happen is you're going to see a trait, which would be a very similar string across a whole population. Okay. And you're going to say, okay, that is exactly the same for the entire population. Therefore, it was selected for. Okay. Now, if you see massive variation within part of that string or the whole string, then you're going to say that it was neutral. You know, that it's going to end up Hardy-Weinberg distributed. It's going to be entirely neutral. Okay. If you see no copies at all of a particular string, or a particular string pops up in just one sample, then you could say that may be negatively selected. So now you know. So now you got purifying selection. That thing is never going to have offspring, right? So that's purifying selection. So you got those 3 things. But you can take your data, you know, which is just the same as if you were to go and look at an organism and say, oh, it has 4 limbs, it has 2 eyes, it has this, it has that, right? And then you go to the next organism and you catalog that. But with genomes, what you're doing is you've got actual strings that you can look at. So you've got actually very, very, very specific strings that you can look at. And now from that information, you can determine a whole bunch of things. One of the things you can determine is if there are coextensive traits, coextensive genes, basically. If 2 genes are linked together, okay, what you will see across the population is you will see everything has gene A, but a very few things don't have, or in one particular species, you'll notice they don't have B. Okay, but everything that has A has B in most of the populations. But then you'll notice that B, the string B, is not conserved within the population or across populations. And you could say, oh, something's up here. Okay, we've got a gene that's always appearing, but it doesn't seem to be conserved at all. So we can suspect that it's linked to gene A. Okay, and then you go and you look at a bunch of other species, some outliers, and you find out that B is gone entirely, all of a sudden in this particular branch. So now you know that a weird happenstance event occurred where a recombination occurred between those two genes, and gene B got left in the dust because it had no meaning. Okay, so I mean, there's a lot of things like that mathematically that you could predict that are the theory of natural selection, or the mechanism of natural selection. But when you say mechanism of natural selection, we think of this trivial thing, just a filter, right? That there's going to be a filter, and it's going to make the most fit survive. That's all bullshit. That's all been left behind 20, 50 years ago.
Sober's been very behind, because that's one of the, Sober's.
I'd have to listen to Sober again, but I think he got a few things right. Let me see what he got right.
Well, he said the first thing is that natural selection is a collection of models and sets of mathematical principles or truths.
Was that Fodor against Darwinism? Was that his paper?
I don't remember. I've read so many. Pigliucci had something like a title like that. Misapplication of evolution, or I forgot. So there's I forgot the exact paper.
Yeah. Okay, but what I'm saying is that there are, you're not going to find a law like F equals ma, right? Well, you're going to find some things like Hardy-Weinberg equilibrium. Okay, if there's no selection at all, that's kind of like the null hypothesis. You're going to see that Hardy-Weinberg distribution. And in fact, if you go look at if you look at sickle cell, the sickle cell gene, the gene for sickle cell anemia, if you go look in Africa, you're going to find that something weird is happening with those two genes, where the heterozygous combination, A and A mutated, are distributed through like 50% of the population. And that's all natural selection. That's all mathematics that we can look at. And that mathematics is fairly well defined. And we can say, okay, that's popping up in Africa, but if we go over here in North America, we don't see it at all, right? So from just the data, we can predict something about.
Yeah, Fodor's not going to dispute that.
Yeah,
he definitely wants to say
that is the theory of natural selection, Danny, and so if Fodor's not disputing that, then he's not disputing.
No, you're suggesting that. You see, predictions. I'm not interested in predictions per se. You can predict things and not explain things at all.
Okay.
What Fodor is contesting is explanation. What explains what you're seeing in terms of?
Well, we know the explanation from the other parts of the theory of evolution. Okay.
No, we're just talking about in a case where we rule out all the other mechanisms like genetic drift or whatever. Okay.
Right.
There are cases in which they're going to say natural selection is the mechanism, the sole mechanism. Okay. That's what he's contesting, right? He's not contesting that you can make great predictions about what is happening.
I see what you're saying. So you think, but that would be an entire straw man of the entire theory, because nobody is saying that a organism is going to. Okay, so if that were the case, then we could have genetic variation in a population, in a world, in a universe where there were absolutely no ecological effects at all.
No. You
Oh,
need
hang on a second. That's what you said.
No, you need look, natural selection, if it happens, according to what we just understood, there needs to be an impact on organisms from certain ecological variables, right? The whole point of natural selection is saying, hey, the environment is interacting with the organism in a way where the organism is now more fit. Okay. That now basically genetic drift is that, but take the fitness out. Okay. So the idea is that they want to say that there are going to be cases in which it's that natural selection is the mechanism rather than some other mechanism. And so that is what Fodor is attacking, right? And I think he actually would have arguments against the other mechanisms, but but I think that that's peripheral. The point is that there are going to be biologists that say, hey, in this case, the way that the allelic frequencies are changing, that's because of natural selection. They're going to say that, and that's when Fodor steps in and says no.
Okay, so we have this difference in Africa. Okay, and we know that Africa is a different place. There's some different environment in Africa.
Mm-hmm.
So we have the African environment and we have the North American environment. Okay. And we see this difference in the genes, very significant difference in the amount of sickle cell anemia cases in Africa. And we see that. There's a heat map I can show you. Okay, we see that is the case. And we're saying that is because of natural selection. It is. It's a fact.
Yeah, that's what Fodor is disputing, given his argument.
Okay, how can it not be a fact if we're seeing this very specific difference? Not only are we seeing this difference, but we can predict that if mosquitoes hit some other country like India, which they do, that we will see the same exact features.
Well, the point is that, and this is Fodor's point, right? Natural selection, as when we invoke it as an explanation, cannot ground any of those counterfactuals. Okay, so let me give you an example. If I trip, okay, right, this is not just for you, this is for your audience. I know you might already know this. If I trip, we want to explain that. Okay, well, let's say that.
Okay, could we stick with mosquitoes and malaria?
No, because
okay, but no, you give me a counterfactual that has to do with mosquitoes and malaria.
I need to. Do you understand why explanations and counterfactuals go hand in hand?
Yes.
Okay, well then maybe your audience does not. Maybe your audience does not, and I want to explain for their sake.
But the audience has heard all of these examples before.
That's what I want to explain the explanations and counterfactuals. I think you should let me
go ahead. Explain to the audience.
I'm not even saying you don't understand. I'm just saying that maybe there's someone in the audience that doesn't understand. Okay.
Right.
Okay. So very simple example. Right. I trip. I want to explain that because there was a rock in front of me that I tripped. If that's an explanation, then it grounds the counterfactual that had there not been a rock, right, then I would have not tripped. That's a counterfactual. Okay. Basically, a counterfactual is when you're taking what's true in the world and you're making it false in another world, right? And the idea is that causation and explanation go hand in hand with counterfactuals because explanations ground counterfactuals. That's all I wanted to say.
Okay. Do that with mosquitoes and malaria. Okay. Now, if mosquitoes are introduced, malaric mosquitoes are introduced in China, okay, or if mosquitoes are not in China, then what we expect to see is we're not going to have the same distribution of sickle cell anemia genes. It's going to go random. It's going to suddenly appear as if it's just drift, right?
Okay, did we get that from?
There are no mosquitoes in China, right?
Okay.
How does natural selection not ground that?
Yeah, the question is that the way that you've come to know that if there's going to be an explanation for that phenomenon, right? And I'm saying whatever that explanation is not natural selection. It's going to be something particular to that in ecology and those organisms.
But natural selection has to have something to work on, right?
That's what Fodor's working on is an explanatory notion. If A works on B, is causal.
Okay. So if natural selection works on the fact that there are no mosquitoes in China and there are mosquitoes in India.
Okay.
okay, then we're going to see this difference in the population. Okay, but natural selection is what is responsible and what explains the difference. What else explains the difference?
So once again,
You
right?
don't like the taste of this gene?
Maybe
So
I'm not too familiar with the example, but you're saying that, okay, there's malaria. I understand that malaria is somewhat resistant to mosquito. Sorry, there's mosquitoes with malaria. Sickle cell makes it such that malaria is not really a problem. Okay. So you're saying that if we introduced a population of mosquitoes to China, where there's no traits of no one in China, as far as I know, suffers from sickle cell to the capacity that Northern Africa does.
right.
Then yeah, we would expect some changes in maybe what do you in terms of the population of mosquitoes in the area that's going to go up, right?
Let me explain, and maybe you don't understand how it works. If there's if there's a sickle cell mutation, right? And then there's the normal. So we have N and S. Okay, if you have two N's, you're susceptible to malaria.
Right.
If you have two S's, you die before you reproduce. Okay, but if you have S and N, you outsurvive people with just NN, because now you,
at least in Northern Africa, right?
In India and all the places where we see malaria, basically we see this pattern, right? So something has happened to the population. Something has been selected. The population has been carefully selected so that the heterozygous having both N and S are at least 50% of the population, or some very high percentage of the population. And you wouldn't expect to see that if S had no advantage at all, because SS kills you, right? SS would have been just wiped from the population. But now we can look at that and we can predict that everywhere where there's malaria, we're going to see, and I may have some of the science wrong on this, but I'm close enough that I think we could back it up. Anyway, I'm waiting for CRISPR to pop up and kick my ass, but anyway, so there's something going on here, and that something is natural selection. We know that these particular individuals or these genes have been selected for in a very weird way. And that is not a trivial prediction at all.
Where's the prediction coming from?
It's not tautological.
Where's the prediction coming from?
It comes from how genes combine in populations over time.
No, it comes from our knowledge about malaria. It comes from our knowledge.
No, not at all.
So you don't need. So you're telling me you can't make a determination or prediction. You can rather without knowing anything about malaria and mosquitoes.
Yep. Okay, if we find a population that has two genes, okay, X and Y, and we find that same pattern of X and Y, all in 50% of the population, we don't know why it is. We know nothing about mosquitoes or malaria at all. All we know is the genetics, right? We can tell you that Y in the heterozygous state is an advantage.
Okay, why?
Tell you anything about
how through the mechanism or theory of natural selection?
Mechanism of natural selection.
No, they're models there, right? That we've derived from previous experiences.
They're not models. We use models to figure it out, Danny. What else are we going to use?
Okay, so models
but we can tell you that this trait Y, okay, we can call it a trait, okay, has got to have an effect on a population and be naturally selected for such that there is a preponderance of X and Y heterozygous conditions.
And I'm telling you that you don't get that from the theory or the mechanism that is natural selection. You get that from being in past experiences, deriving those models, and then seeing a consistent pattern. And then when you see that pattern, you're going to make a good prediction.
That pattern is natural selection.
Well, look, the pattern doesn't cause anything.
The pattern doesn't cause anything.
Look,
something caused the pattern.
Oh, okay. Is the pattern natural
what
selection?
Caused the pattern?
Is the pattern? Go ahead.
What caused the pattern? Why is the pattern there?
From our experiences in the field.
No. Experiences in the field don't cause patterns. Patterns are...
No, they do. Look, I'll give you an example. In my experience, you and I get in arguments. Okay.
Right.
And so then I can make predictions. I can create a model about when my voice gets to a certain pitch, how speed will respond. Okay. We can model, and there'll be patterns. And then the next time it happens, all we see is the high frequency of my voice. And then we can make, okay, this is an argument.
Right.
Okay. The point is that how I came to that is experiencing multiple scenarios in which I raise my voice and you respond in a certain way. Okay. This is how we get the pattern, right? We have to analyze the particulars. We don't go from top down to a theory of Danny and speed. We go from bottom up. The experiences of speed and Danny are such that when Danny raises his voice, speed responds in a certain way.
I'm sorry I missed all that because I was distracted by the pitch of your voice. But
we
okay.
Really
okay, that's all bullshit, Danny.
I don't think you're going to be able to show that.
I think I'll be able to show that that's bullshit. Okay. So we have a pattern. We find X and Y in 50% of the population. We find Y in 25, or we find Y in 0% of the population, and we find X in 50% of the population. So we find XX in 50%, and we find XY in 50%, right? Okay. So that is the pattern that we found. That pattern is there even before we did the test and found out it was there. The pattern was there. You agree with that?
I'm with you so far.
Yeah. We didn't create the pattern by looking at it, right? So then we look at that and we say, aha, because of that pattern, we know that the XY heterozygous trait was selected for. Because of natural.
But I'm asking how you know that.
Because of the law. Because we understand how diploid organisms combine.
How do you understand that?
How do we understand? Well, it starts with Mendel.
You have to it's going to start with empirical observations of these scenarios that involve those placeholders. That's where it's going to start.
Right, and we figured out.
Not from a theory.
Okay, we figured the theory out based on Mendel's experiments. Then we found genetic drift. Then we found mutation. There's copying. There's mutation. There's populations. That's called natural selection, Danny. That's why scientists lose their shit when you say we don't need it. It's because no, it's just absolutely the causal mechanism of it. We have a filter, okay, something that is filtering. Okay, we find this XY case in parts of the world, but not in other parts of the world. So we can say that in that part of the world, the part where we have the XY, okay, we know that there is some kind of a selection force.
Yeah, you're not getting that from the theory, though.
We're getting that from the theory. No, you don't need anything else. We can go home at this point. We can write a paper and say, hey, we found out that the XY heterozygous trait is being selected for because of the data.
Yeah, because of the data is going to be that pattern. I'm saying, where is the pattern coming from? Is it coming from the theory of natural selection? Yes or no?
Yes.
No, that's just false.
Well, where's it coming from? Where's the pattern?
I already said it. The particular experiences with the placeholders.
Interesting. Okay. So you're saying the theory should cover all of the particulars, is what you're saying.
No, I'm saying that our models and our patterns are derivative from the particulars. Okay. Getting our hands dirty in the environment with the animals and the anatomy and the genetics, we come to know, we come to recognize patterns and we model those. And then when we see those patterns in the future, we make a prediction about what's going on. That's totally fine.
Darwin didn't know any of that.
No, well, what does that matter?
He went on and tried to find it.
I don't see how. What does that matter?
Well, what Darwin did is he went out and collected a bunch of patterns, right? And he said, from these patterns, I can derive a theory of natural selection. And that's what he did. Okay. And that theory has withstood the test of time up until now. Of course, we found a whole bunch of other, little compounding theories that gave us even more information.
Let's talk about Darwin. Then I think Darwin is a good example here. Okay, I think you presented a great example that supports what I'm saying. The point is that it's not like Darwin went to the Galapagos and then derived a pattern without going into the particulars of the Galapagos, whether that be all the various islands and its unique ecological variables and its organisms, its respective organisms. What he did
collected
was
the data.
He collected lots of data. That's
Okay.
what
I'm sorry. I did not mean to jam your mouth.
That's what I mean when I
hope
say
I didn't hurt you.
the way that
You're my sweet baby, and I don't want to hurt you.
Scott, you're not muted.
Oh, sorry. Sorry, I was reassuring my dog that I was not being mean to her.
Okay.
This is what I'm saying, right? That if Darwin modeled and found patterns, he got it from getting his hands dirty. He took data from the particular scenarios, from the particular ecologies, particular organisms, and then came up with quantified lots of stuff, and then derived patterns from it. And now we can use that for predictions, right? We can go out, and the next time we see that pattern, we can make predictions about what's going on with selection. There's nothing wrong with that.
Okay.
Okay,
and then starting in 1920, starting with Mendel, we found more about the patterns. We found a lot more about the patterns. And then starting at about 1920, they started theorizing about genes. And then in 1950, we discovered DNA. And then since then, we have come up with the mechanisms behind the theory of natural selection. So what are you complaining about? We have the mechanisms. We can show you the mechanisms behind the theory. Okay. And please just listen for a minute. So now we collect data and we take a look at the population in Africa and we see this XY, whatever. And we say, okay, something is up. Something is causing this particular pattern. Okay. We know the mechanism of genetic recombination, of mating with mutation, variation across populations. We know all that. That's our mechanism, right? Okay, what is it that's operating? What are the particulars of that mechanism? That's the next phase. Now we go and look and we find out, mosquitoes, malaria. That all comes after the fact. We knew a lot before then because of the theory of natural selection. We don't need anything. We don't need to know anything about mosquitoes or malaria until we come to the point where we say, okay, what is it that is feeding? What is it that is creating these parameters that are going into the mechanism of natural selection that are causing this pattern?
I think I'm going back to my original point. My original point is that these patterns that you're using to make good predictions, I think they're good patterns, good predictions. Biologists are doing a good job, okay, and making models and all of that, do not come from natural selection. I've already said this.
Okay, you could not. Okay, you could make a prediction with just the pattern, but you wouldn't understand the mechanism. But we understand the mechanism and the pattern, and afterwards we find the causes. We find the particular causes afterwards. I don't see what the complaint is. What is the complaint?
You're going to have to repeat that. I missed it.
Okay. Okay, we go out in the field and we find the XY. Okay, so now we've got the XY and we know that something is up that is selecting.
How do we know that? How do we know that?
Because we see it in the pattern. We know something's up, right?
No, when you say we know something's up, we're recognizing a pattern already.
Right.
Okay, so I'm saying, where did we get the pattern? Did we get it from natural selection, or did we get it from a generalization that we've made from analyzing multiple particulars?
We get it from the data.
Okay, the data. Where do we get the data? From the particular scenarios.
Okay, the data is the pattern, or the pattern is the data.
The data
pattern is in the data. Okay, we're out in the field.
I'm making the claim that we're getting that from getting in our hands dirty. What Darwin did essentially is go to the islands, go to the organisms, and then quantify all of his findings.
Well, we don't have to do that.
Well, I'm saying that's where it starts. You may not have to do it anymore because of the good work biologists have done to already formulate these models and these patterns, because people like Darwin have already done it, right? So when you're saying that oh, look at this pattern. We don't even know anything about the alleles. We don't know anything about the ecological variables. The fact that there is this sort of pattern, we're justified in thinking that there's a selection process. I'm fine with that. Fodor's fine with that, right? He's saying that you're not getting that from the theory, though.
Yeah, CRISPR's got it. You can't say that math that uses differential reproductive success makes good predictions, but differential reproductive success isn't used to make predictions.
He's confused. I talked to him about it 2 weeks ago.
No, he's not confused at all. In
very
fact,
confused. Yeah.
No, Danny. In the past, you told me CRISPR gets it, but I don't. You're telling me.
I think now you might be getting it more than CRISPR, because I talked to CRISPR a week ago. Okay, and he said he was obfuscating. He wasn't clear with or concise with his points, and he said a lot of gibberish. Okay, so I think you actually probably understand it now after some time more than CRISPR.
Danny, let's see. Okay, we're going back to XY. We're going back to this XY heterozygous. Okay, so we collect the data. That's one thing, right? And now from the data, we can tell you that there was a reproductive pressure for that heterozygous pairing, right? Okay, we can tell you that. We know this because of the theory of natural selection. Now, we can tell you exactly how that happens because we have population genetics. We know about diploid organisms. We know how they combine. That is the mechanism. So now we can tell you how the mechanism actually works to create that XY. So we have that part, right? You agree that the theory of natural selection and evolution is all about how those things combine and how they spread in populations. That's what the theory is about. Okay, so we have our data, and we go down here and we say, okay, so Y is up to something. The XY combination does something. It produces an advantage. We know that. Now we go back out in the field and we start collecting insects, diseases, information, and now we can explain the particulars. The particulars we have basically gone top down. Of course, you have to start with data, but no, we don't need to start with data. I can make up a completely fake biology where there's Monster Z who likes to eat things that basically have XX and doesn't like to eat things that have XY. And Y happens to kill you. It's poisonous, okay? YY is poisonous. I can create an entirely artificial world from the theory of natural selection and show you how the populations would evolve. And it will match what we find in the field. So what is wrong with the theory?
Yeah, I already said this, but I can go in different directions here, okay? Because I feel like my point is not being understood in terms of how we come to patterns and models, right? I'm saying these patterns and models are not coming from a unified theory or a mechanism per se. I think they're coming from getting our hands dirty in the ecologies and getting our hands dirty with the anatomy and physiology and the biological traits of organisms, okay? And that's going to vary across various scenarios, different ecologies, right? So, and then we can make generalizations about patterns, and then when we see those patterns in new ecologies and in new organisms, we can make predictions. There's nothing wrong with any of this. Okay. The point is that number one, I think you could explain everything very, very well without saying because of the theory of natural selection or because of natural selection. You can give a perfectly good explanation. Okay. Now saying that it's because of natural selection is superfluous, in other words. But I think that you have to engage with Fodor's argument, right? Because I'm trying to respond on the level that you're giving me, right? And that's just that. Natural selection, right, is intentional with an S, okay? It's not extensional. Causation, explanation is extensional, okay? And as long as that's true, there's nothing that's going to move Fodor's argument.
Hey, gentlemen, we've been at this for just over an hour. I'm just wondering if you wanted to continue or you wanted to let people in to give their viewpoints, or how do you want to do this?
Yeah, you want to have a go. I'm getting kind of tired, Danny. Sure. There's a lot to unpack there, but yeah, the interesting thing is historically how we develop theories and how we develop explanations. And granted, Darwin went out and collected a bunch of finch beaks and moths and various other things. And he came back and he started thinking about it. And then he came up with this idea, this overall general mechanism for causation, basically, of, how could this be? And in the last 150 years, we have refined that to the point where there's all sorts of other things we found out, like drift and gene linkage and all these other things, and they all fit into the theory, and it's all theory of natural selection. And I don't think Fodor has a leg to stand on criticizing any of that, nor do you. And that is my summary. Let's not argue anymore. But are you willing to let Chris Brennan have
anyone?
Okay.
So I'll put the invite out, and Speed, you can control who gets in.
Oh no, you control who gets in. I'm gonna go get some coffee, Scott.
I'm gonna make coffee too. 1 second.
Okay, so
literally 1 minute. I have already made it.
Oh, yeah. Okay. We need an intermission, so I'm gonna start.
Oh, there we go. There we go.
Yeah, we need an intermission. So let's. Where do I have that? Okay. So Peter says this is amateurish and it takes too long, but I don't care. Oh, damn. Warm yet.
I think it's cute y'all would decide to wear the same color shirt.
Yeah.
Oh, yeah, we did that.
Hello.
Solidarity.
Hey, by the way, Speed, check your email.
Oh, my God. No. What? Oh, no. Now what?
You told me to get someone's email, and I did.
Oh, okay. Give me a minute.
Holy shit, you guys really are wearing the same shirt.
You guys go ahead and fight. Danny's is newer than mine, though. I've watched mine more times.
Hey, Scott, I got a bone to pick with you.
Okay.
Oh, he's actually skinnier than I thought. Interesting.
The bone I had to pick with you is that I want to see more of your dog. Put him on camera.
Oh, well, I'm gonna let sleeping dogs lie, but I will definitely change my avatar. Which one do you want? The little one or the big one?
The little one.
All right, there's Gibbs right there.
Aww.
Make yourself full screen so I could see it better. I'm blind. Oh my God, he's so
what did
adorable.
he do? Why is he looks so?
I know, right? He looks so.
What
so
did he
sad.
do wrong?
Well, no, he lives in a state of existential dread.
Of course. So he's like Danny.
I try to comfort him, but every little sound makes him jump.
How old is he?
He's probably going on 8 years old now.
Oh my God, he's so
getting
cute.
up there. He's my cute little old man puppy. But anyway, yeah, that's Gibbs.
And he's biology student. That's just precious. By the way, Scott,
Jason?
can you please switch to the other layout?
Jason, you didn't talk to Jack Angstreich in the last few days. Someone told me.
Thank you.
Did.
Nope, wasn't me.
It was someone else.
Nope.
Hey, Degree Snob, how you doing?
Do you know that Jack Angstreich and Speed debated? Did you know about that?
No,
Jack
really?
yelled at him and called him dishonest. Basically, did everything I did to him. It was so funny.
By the way, Speed, I gotta ask you something. What the hell did you do to Richard Manson?
Nothing.
He had nothing
What?
but bad things to say about you. I went on.
Where?
I went on Wild Heart's channel because he was live. I said, Speed wants to talk to you, and Richard Manson is like, no. You shouldn't talk to Speed of Pudding. I'm like, what the fuck did he do?
What? I was on his channel and we had a good talk, and he's always
Well, apparently not.
isn't he the one that always doesn't he always come on and say peace and love to everybody and
Yeah,
all
peace
this
and
bullshit?
respect, and I know. It honestly comes off.
What
It
the hell
honestly
did I
comes
do
off.
to
As
him?
I don't know, but but every time I hear him say peace and respect, I cringe. I don't know. It's just the way he says it.
Wait,
Yeah.
how cold is it, Jason, over there where you're living?
Nobody cares. Just kidding.
Yeah, it's a little chilly.
It's 60 degrees here.
What is it?
Okay.
It's
Okay.
60. Yeah, it's
Okay,
probably
don't we
like
need-
45, 50.
Do we need the
most.
man of the hour in here, CRISPR? Like I want to see him argue with Annie.
CRISPR probably doesn't think it's worth it.
I think CRISPR has an error or something. It's like some sort of
00000.
I think we broke CRISPR.
Maybe it's an error that he can't come into the StreamYard. Maybe that's what he's doing.
Seems like this discussion is all around like what is natural selection is like if it's the processes, if it's the underlying processes, and we're just describing it as natural selection.
Hey, buddy.
Jason, where's your neck?
It's all tucked away.
I was gonna say because it's like where's your neck? It's like
I got a sweatshirt on.
It's like you're hunching. It's
I gotta work out.
back.
I haven't worked out yet. I just got
Yeah,
up.
you
and I
look
saw
like
you.
Emery more Nazi.
I look like a Nazi.
Well, more Nazi.
Oh.
That's racist.
If you zip your button all the way to the top, you look more Nazi.
Oh, cat likes typing.
Oh, yeah,
get in
yeah.
here. You
Hey,
get in here.
I am like 100% like German. I'm like all my family's
Ooh.
from like.
Oh, you're German. Wow.
Oh yeah, oh yeah, big
Germans,
time.
Germans can be redheads.
Apparently.
There's ginger Germans.
Definitely lots. Yeah.
Oh, okay. I didn't know that.
Wait, I don't see him
Even
as
though
a, wait, are
even
you
though
a
Hitler
ginger?
didn't like redheads.
Are you a
Hitler-
ginger? You don't look like a ginger.
Yeah, I am. Yeah, it's kind of gotten blonde over the year, but yeah, I have red hair.
So was there selection for that trait, or did Hitler select for that trait? Red hair?
Hitler did not like redheads.
Oh
He
boy.
didn't? I didn't know.
No, he thought that they were like not like that he wanted to get rid of redheads. Like it's
Interesting.
not.
Like to what extent? Like the same extent, like as the gypsies and homosexuals?
I
or-
don't think so. I just know that it was perceived as like not like not not of the pure, not the pure Aryan aspects. I don't think redheads are seen as like it's not like there are a bunch of redhead Nazis running around. I think that I don't know. I'm speculating. I have read something about this that redheads were not seen as pure in terms of the Aryan kind of Aryan viewpoint. But anyways.
Okay,
But-
Smokey is
Smokey
in the
here?
back room, but I don't know what to do.
Well, you know me. I think we should let him in, and then if he's
Why
rude,
not?
just kick him out. He
Uh,
won't be rude with Speed. Okay, I'll defend you if he's rude. Okay, I promise.
what is the vote? I wanna see what-
I don't have a problem with Smokey, but you could always
Speed,
just boot
do you
him
want
at any
me-
moment.
Okay, look, Speed. I need to ask you something. Do you honestly want me to answer that? Do you honestly want me to vote?
Speed, just
Yeah.
let him in, and if he's rude, just do what you do to me.
I want you to vote. No, it's just that some of the shitties.
Well, then, well, I'm gonna vote yes because I'm
Some
biased.
of the shit he said recently, like in the stream with you, Midnight, was totally unacceptable.
I know, but I know. As a bi man, I really don't care what he says.
Well, look, just look at him as a robot that might contribute to the conversation, and then don't think of him as a person. Right? Just think of him as a voice bot. Okay. That might contribute to our conversation or
With no
a conversation.
history. With no history.
Yeah, robots are not responsible for what they do.
Smokey, some of the hate rhetoric that you came up with recently, and some of the ways in which you basically described gay men is offensive to me. So please leave. I don't want you in my room. But, clean up your act, and hell, we'll talk later. Because I don't have.
It's kind of lame.
I actually like Smokey in some manner. Of course, I like everybody.
Because he attacks young Earth creationism. If he was a young Earth creationist, he would not even be in the back room.
If he was a young Earth creationist, I'd let him in.
Okay. So stuttering. So CRISPR wants nothing to do with you, Danny. I don't
Yeah,
see the
because he doesn't
point
know
in
what
the
he's talking
conversation
about, right?
until Danny, he knows more what he's talking about than you. Okay, you may know
That's just a
philosophy, but he
claim.
knows science. Well,
Yeah, I'm giving a
I don't know
philosophical
who.
argument.
I don't bow to you, speed, and your. Okay, let me see what the fuck. I don't bow to you, speed, and your unjustified, unsubstantiated, subjective moral standards.
What? What?
Wait, so
I mean,
can I run the argument with Jason? And I'm going to do it a different way.
Where did
Okay?
you read that, by the way? What did you
Private
just-
chat. Do you not see the private chat?
Oh, no. Okay, I have a couple of
Is the
hundred.
challenge
Can I run the
kind
argument
of
with Jason?
woman
And then
interested in you?
it's going to be a different.
Wait. What?
I want to run the argument against Jason, please, with a different approach. This is a completely different. I'm experimenting with this new approach.
go for it.
Okay, so I'm going to do it. Okay.
Jesus Christ. I'm mute.
Suppose
Sorry.
you're breeding dogs. Okay? And
Alright.
over generations, you breed a dog that has long hair and brown fur. How do you know what explains why that dog has brown fur? How do you know whether that the breeder is choosing or selecting for brown hair or long hair? How do you know?
I don't know. I mean, I know I kind of have like a background of this because I mean in this discussion, so I would be inclined to say because we have a model that we have constructed that we know how dogs breed and what are the results. I mean, another way of looking at it would be if I was just like off the cuff, I could be like, oh well, I've seen that happen.
I'm saying a breeder is doing it. There's a person that's breeding
Yeah.
dogs.
There's a person's breeding dogs. Yeah. Okay.
Okay. Then never mind. Then what were you saying? Why can't you
No, I
just
was
ask the breeder?
You mean like what I asked the breeder? Did you breed this dog with that dog? Sure. Okay. Yeah. That's a
So the idea is
reasonable
that
okay.
you have a population of dogs who long hair is coextensive with brown hair. Okay.
Right. It's fine.
You want to know whether it's the long hair, brown hair, or even both. Right. So you ask the breeder, which one are you selecting for?
Right.
And the breeder says, I desired long hair.
Okay.
And so from the desire, from the belief, you derive what can differentiate between the trait of interest, which is the long hair, and the trait of the disinterested trait. It so happens that
it was the desire.
Hair, right. The content of the desire. You see, desires have the right content to tell you to distinguish between the traits, and that allows you to make a good explanation.
Okay. So are you making a connection then that the processes that underlie natural selection that humans have to investigate those processes to understand the reasonings why those processes are occurring, and that without understanding those, if I just say natural selection, that I'm not getting to the heart of why those processes are interacting? Like, I think
that's definitely part of it. I think the most fundamentalist thing is this, right? The way that you distinguish the traits is deriving the content of the explanation. The explanation has to have the right content to tell you to differentiate them, right? Desires have content, but there's no content in natural selection that can distinguish traits.
Okay, can you back up? I missed the original.
I brought feedback in.
Okay, I missed the original. Okay, the breeder is selecting for what?
So so do you want me to start over, or do you want me?
Yeah,
Start over. Okay.
Start
so
over.
Look,
so I can read it.
There's a breeder. Okay, he's breeding dogs across multiple generations. Okay. What you notice is that in the most recent F generation, okay, that all the dogs have long brown hair. Okay. And so you're wondering, what was the breeder going for? What was being selected for? Was it the long hair, the brown hair, or both? How do you find out? And the thing is that what we said is we have to consult the breeding company or the breeder, right? The breeder company is going to have desires, right? And those desires are going to have content to distinguish those traits, the coextensive traits, right? So let's say we ask the breeder says, I wanted, or I believe that long hair is good, okay? Which means that the content of that desire, you're able to distinguish the traits that you see in that most recent F generation, and then come to know that the brownness of the animals doesn't matter. Had they been pink, had they been black, whatever, right? We still would have expected to see that population with long hair, because the trait of interest is the long hair given the desire of the breeders. And so what this is supposed to show you is that the way that you distinguish the traits is the content of the explanation. The explanation here, in this case, is the desire to breed dogs with long hair.
Okay, but wait a second. Let's apply this directly to natural selection then, because we're talking about like this aspects of differentiated reproduction and the environmental pressures that are being placed that result in long hair, like, you know, for whatever reason. But that pressure doesn't require human interaction or involvement to observe that pressure, for that pressure to actually occur. So like if humans if we had no idea what natural selection is, and we had not described it as a theory, that those interactions and processes would still be occurring. And okay. And so if we didn't have if we didn't know, we hadn't put together a model, we hadn't said our observation, as we look at what's actually happening, we have formulated this natural selection model, which describes it. So when we say that this is what's happening, it's caused by natural selection. If we hadn't done that, those things still would have been occurring.
Yeah. Can I stop you there, or do you want to finish?
No. Maybe I'm not understanding
let's just take that exact example, but take out the breeder, and we're in a naturalistic environment, environment. Okay.
Yeah.
We still see this exact same generations. We still see the dogs with the long hair and brown fur.
Okay.
Now the question is, did the environment care, so to speak, care or select for the brown hair, for the long hair, or both? Now, I think we can know the answer to that. Okay. But what that's going to take is a serious investigation of the ecology and of the physiology, anatomy of the organism. Okay. It's not going to be known through a theory, because there are just too many localities.
Well, okay, but a theory is essentially a set of hypotheses that have been evaluated, that provide us to evaluate and to know like why something is occurring. And certainly a theory, you know, technically,
they ground counterfactuals, Jason. They ground counterfactuals.
I agree.
Look, I'm on caffeine right now. You need to let me know if you need to finish your thought.
No, it's fine.
I already got the disposition to interrupt. Okay.
I'm okay with that.
Okay. So the point is this: that with the breeder, what grounds the counterfactual that had the
breeder not had the desire?
Rather that had the dogs. If the dogs had black colored hair, there would have still been long hair. Okay, because what grounds that counterfactual is namely the desire of the breeder. So the idea is that what I was saying earlier is that the explanation and the counterfactual must be linked. If the explanation cannot account for the counterfactual, it's no explanation according to Fodor. Okay, I don't know if you heard earlier. If I tripped over a rock, if the rock explains my tripping, then it's going to ground the counterfactual. Had the rock not been there, I would have not tripped. But if it doesn't ground that counterfactual, if it's true that had there been no rock, nonetheless, I would have tripped, not an explanation.
I mean, you're saying that like if we're talking about like these coextensive traits, like traits that they're not being selected for, but they are a result of the process through the long hair that the dog has got.
Yeah, it's right along or spandrels. That's what I think. That's what. Yeah.
Yeah. I guess I'm just not understanding that we have these interactive processes. I guess I'm getting caught up on the fact of, you know, saying that natural selection in and of itself is not causing the dog to be black, you know, But if there are
the
these
intentional explanation is
right, but but the interaction of the processes are resulting in the dog being black. Now, is it causing the dog? It's kind of like a semantic term here. Like, what does it mean to cause? I mean,
I don't think we need to get that deep. I think we only need to get that deep if you think that you're not sure about this relationship between counterfactuals and causation or explanation. I think, right? We don't need to analyze, I don't think, explanation and causation any further if we agree that explanations ground counterfactuals.
Okay, so we've got we have this string, and it consists of L and B, long hair and brown, right?
Mm-hmm.
In a population, and every single member of that population has LB. Okay, so LB becomes one trait.
They're two different traits by definition.
It's you might define it that way, but geneticists
and you're just talking about a set. You're talking about a set of traits, not a trait.
No, hang on. Okay, so if we're just looking at genes, we're going to see LB, and we're going to see that sequence everywhere, and we're going to say, okay, we've got one trait here, LB. It's popping up everywhere in this population. We don't have enough information to know anything else. So now we go out and we look at another population, and we find that population has all L, but it has some B and some not B.
Okay.
So that's some mutated B, right? So now we have two populations. So now we have more information.
Yeah.
We don't know anything about brown hair. We don't know anything about breeders or anything. Okay.
Yeah.
And these two populations, basically, we can't find nothing else different about them. So we know that L is being selected for, and we know that B.
I don't have any problem.
We know that. Yeah. Okay. We know that L is being selected for, and we get another population, and it's got L, and it's got it's got no B at all. The gene is gone.
Yeah.
Entirely, right. And this population seems to be doing just as well as the other two populations. So now we know that B was probably genetically linked to L. And we do this all from the theory of natural selection.
Look,
all from natural selection. We can tell mathematically, Danny, what is going on without knowing anything about brown hair.
I know what you're saying. The point is that in your whole entire, what you just said there is interesting. And I think that that's how biologists make predictions. But notice that and nowhere in your narrative you provide an explanation.
Hang on a second, Scott. Who just popped in and popped out?
Oh, that was me. I left for a few minutes and then I came back.
Yeah, look. Nowhere in your narrative did you include an explanation. You're just talking about predictions.
No, we found this data, and now because of the theory of natural selection, we can tell you
what explains the data.
Are you the theory of natural selection?
No, because it can't differentiate between L and B.
Okay, the theory of natural selection just differentiated between L and B using the data, and the causative mechanism. Now that we know that B tends to drop out in some populations, it tends to be present in some and not in others within a population.
You're just changing it.
No. From this, we can tell you. We can go all the way back and we can tell you, we can retro predict basically the causative mechanism, and it was entirely
that's not
genetic recombination. And we don't need to know anything about brown hair.
Let me just tell you, because look, I don't mean to talk over you this way, but look, the point is that you're just changing Fodor's example. It's stipulated. One second. The conundrum only comes when there's a recognized coextensive trait, right? If you're saying that, look, this is the case that's not coextensive because you're giving hypotheticals in which L is not coextensive with B, then you've operated outside of Fodor's hypothetical. The whole problem is that if in an actual world where L is always coextensive with B, then the natural selection itself cannot differentiate between those traits. You have to rely on the fact that they're not coextensive to understand which is the trait of interest.
Right, and it falls flat on the heart and the thump, right? Okay, so So basically,
you understand what
Fodor
I
is
said?
saying Fodor is artificially taking the heart and the thump noise and trying to separate them, right? And I'm saying, well,
he specifically says that in non-actual worlds, right? What you've described in your case is that in the actual world, we see populations with L and B, populations with L and some B, and populations where there's just L. That is in the actual world. Okay.
Right.
There could be a world in which, the actual world could be in such a way where L is always coextensive with B, and you can't appeal to this. What you're called has a name for it. It's called the method of differences, right? That you basically wonder if I take B out, what difference would it make in terms of the population over generational time, right? And if it's the case of this, no difference, then L is the trait of interest more likely. Okay. But you don't have access to that if the trait is truly coextensional in the actual world. So you have to rely on hypotheticals and these possible worlds.
Okay, if L and B are necessarily coextensional. Okay, necessarily coextensional.
I think I know what you mean, but just to be clear to the audience.
Okay, hang on. Just hearts and thump. Hearts. Okay, go ahead.
Yeah, I know what you meant, but I don't want to say they're necessarily linked. I'm saying that they're linked always in the actual world, because to say that they're necessarily linked means that in every possibility, including non-actual worlds, does L and B go together, but that's just not true. We can disentangle them in possible worlds.
Okay, hearts that go thump. We could guess, or we could imagine that those things are always coextensive, that there's absolutely no way to separate those two things. And then we would call that one trait. Okay, we can imagine a world where hearts don't go thump, right?
Okay, yes.
You got a lot of fat around the bells and there's no thump.
Say that last sentence.
Okay, there's a lot of fat around the bells and there's no thump. But suppose, how did you end up full screen?
I didn't do that.
I think, oh my God, now you're really full. Are you trying to aggravate me, Scott?
No, I hit the wrong key or something. I was trying to do something on a different monitor.
I thought you were trying to aggravate me by showing Danny full screen. I have a post-it note over Danny's face. So, and I have a filter on his voice to make it lower, which is why we got along so well during this last half hour. So
I think I'm starting to finally understand Danny's point about the coextensive traits piece, but. No, I mean, I'm not. I mean, maybe
whether you agree or disagree, I don't care. Understanding me is the priority.
Yeah.
I think we've understood your point from the beginning.
Maybe I haven't. Maybe I've just been dense. So
no, it's not easy to understand, and I fail sometimes with respect to explaining it, because the original explanation in Fodor's book utilizes extension and intension. I talked to a philosopher in University of New Mexico, right? Brilliant. He Harvard grad. All I had to say was that, look, natural selection is intentional, but causation is extensional. He immediately understood the objection and accepted it. Never heard of it before. Why? Because he's a philosopher that regularly uses those terms, right? But I had to translate this fucking distinction to y'all in a way where it's a little bit relatable to the way that y'all think in your framework, right? And that what that does is that open me up to all sorts of weird ass objections.
Yeah.
I was talking about intentional and extensional 10 years ago in a forum, but I use it in
then I'll just ask you: is natural selection intentional or extensional?
Is natural selection intentional or extensional? I don't know the answer to that question.
That's the whole that's Fodor's original argument. Speed.
Is it intent? Okay, the question.
It's probably extensional.
It's probably now. If it's extensional, then it's not. Okay, so you know what I mean by extensional, Jason?
I mean, if it was intentional, then the premise would be that the natural selection is intended for coextensive.
No. Oh no. You see, this is
don't use intention.
Okay,
intention with an S.
Oh yeah, that's right. Yeah, okay.
You see, this is why. You see, I have to create ways of explaining the argument.
Yeah. Okay.
Let's go over it again.
Okay. From the top. Okay. I used to play the violin very often in high school, and the worst thing you could hear from the conductor was from the top.
From the top. Right.
Anyways, so the original argument is this. A, Fodor asserts that causation is extensional with an S. Okay. But natural selection is intentional. And if you think that natural selection is is a cause or an explanation, then it must be extensional. But given that's intentional, it can't be explanatory. That's the original argument, right?
How is it
And so
intentional?
because when you substitute the terms that natural selection is acting on, right, it won't preserve truth value.
Example.
So I'm going to avoid the heart thump thump noise, but that is usually the okay. Let's use the frog example.
Use that one. Use that one. That's good.
Okay, so natural selection operates on the heart that pumps noises. Your heart that I'm sorry, did I say that? Natural selection acts on the heart that pumps blood because pumping blood is conducive to fitness in some sense. Whatever your account of fitness is, so be it. It doesn't matter. Okay. But it does not act on the heart, your heart, that makes noises, right? So the idea is that when you substitute the coextension, the co-referring terms of coextensive traits, it will not preserve truth value. And if it doesn't preserve truth value, it's intentional. But causation.
Okay, let's create two statements that where basically we have where it changes the truth value using thump thump.
Sorry, say that again.
Okay, let's create two actual sentences.
Okay.
Where substituting thump thump for heart changes the truth value.
Okay, does natural selection act on the heart?
Wait a minute. Did you phrase that as a question? I mean statements. Let's.
Okay, natural selection operates on the heart that pumps blood, not on the heart that makes noises.
On the heart that pumps blood, not on the heart that makes noises. Okay, what's the other statement that changes the truth value?
So if the heart that pumps blood and the heart that makes noises, those are co-referring or co-extensional. Okay, so if you flip it, right, then it does not preserve truth value. If you say natural selection
operates on the heart that makes a thump thump noise,
that's false.
Okay, not that pumps blood. Okay, so
that's intentional.
So those are the two statements. So you just switch pumps blood with thump thump.
Right. Right. If you the pumping and the noises, if you switch them, it becomes false.
Okay. So.
But then the other premise is, now you might contest this, but it's rarely not contested. Causation,
I'm still working on our statements. I'm still working on our two statements. Natural selection operates on the heart that pumps blood, not on the heart
that makes noises.
Yeah.
Not on the heart that makes noises. Okay. So let's say the other way. Natural selection operates on the heart that makes noises, not on the heart that pumps blood. Those two statements.
I wonder what a biologist what their perspectives would be on this, because like two traits could be very closely, those traits, those coextensive traits could be so, I mean, because it has to do with like that selective pressure, like what those relationships are. Like they could be like mildly coextensive or extremely coextensive.
Yeah. So Fodor wants to talk about in the localities, they're 100% coextensive. Like so, and you can make up stuff, right? It doesn't have to, you could talk in terms of the way that like for instance, Fodor uses frogs eat flies. That can be translated to that's coextensional with frogs
eating BBs
at black dots. Okay.
Frogs do what? What was the last time?
Stick out their tongue or shoot out their tongue on black dots. Okay.
Right.
The thing is that what's interesting in terms of natural selection is that they eat flies. They go for flies, not for black dots.
No, they don't. They go for black dots, actually. Neurologically, they go for black dots. We know.
Yeah, but what's being selected? Look, the point is that they go for black dots, and you replace the flies with like a black bead, right?
BBs,
they will die.
BBs.
They will die. They will die, right? The idea is that if you replace, that's the counterfactual. The counterfactual is that if you replaced all the flies, which have a lot of nutrition or whatever, right, with these black beads, right, then fitness goes tanks.
Okay, Jason, Fodor is complaining that natural selection does not have a theory that tells you whether or not frogs will survive in a world where instead of flies, there are black babies everywhere. Okay. So who the fuck cares?
No, because the thing is that if you look the second, remember, what is Fodor disputing? Fodor is disputing this statement: natural selection explains X, Y, Z. Whatever. Okay, because
okay, let's put it up on the screen again. Oh fuck me, I got rid of it. What you're saying, Fodor says the theory of evolution is supposed to do is not what the theory of evolution is supposed to do entirely.
Let's just do it in terms of, because the artificial selection is such a perfect example, because when we appeal to desires, they're good explanations if we're trying to explain why they're certain traits, because we're asking, had this dog or sheep not had this trait, would you have seen that trait in the most recent F generation? And you can appeal to the content of the desire, but there's no content in natural selection to derive an explanation. So what you have to do is do a lot of work in the environment and with the animal to come to that case, right? Because remember, and I've said this so many times, and I must emphasize it because Darwin, Fodor says the theorist is smarter than the theory. The theorist is smarter than the theory. Starting from Darwin and even before, there's been a lot of work to understand these ecologies, these various organisms, such that you can make good predictions and answer these questions. And natural selection is as a theory, it's just superfluous. You don't need it, right? We already have all the information from the gathered particulars.
But that isn't going to tell you why we have this XY population in Africa without natural selection. It's not going to tell you about that. The particulars are not going to tell you that. The particulars are going to tell you that some people die of malaria and some people don't. Okay. But if you start looking into it, you're going to find more about the genes, and then you're going to have genes, and you're going to ask yourself, why did this happen? And you're going to say, well, natural selection is what caused this particular population to appear. And I don't know why you're not getting that.
So then let's go back to the original argument. Do you think that natural selection is intentional or extensional? And then I'm going to ask you, do you think causation and explanation is intentional or extensional?
Oh shit! What? Oh.
Okay, go ahead, Jason.
That, if I can get the terms right, so I guess it's the natural selection is intentional
with an S,
but causation is extensional. Yeah,
that's the tension. That's the damn tension.
Yeah, I can understand that, but I'm trying to think of a way of describing this, because
Fodor gives two ways out. He says there is a way to make sense of intentional causation, but there's only two ways. Number one, desires actually give you he says that there's content from desires and content from laws that you can use to differentiate the traits, right? So that's why artificial selection doesn't have this problem, right? Because you're appealing to a mind that has the answer. It's cheating, right? It's like, what if we had a book of nature? And actually some responses is this, right? One of the responses of Fodor is that Mother Nature has things in mind, okay? But the point is that if I want to know brown hair or long hair, which one? I can cheat and go directly to the answer that the breeder.
So this framework of natural selection is obviously are constructs that we as humans we're evaluating the data, and we've come up with this theory to explain why things are occurring. But that theory is not all encompassing. There may be aspects where we're like, okay, this is what's getting selected for. It fits with the theory. But if we delve deeply into it, we suddenly discover that there's some really complicated interactions that better describe what's actually going on, of which the theory at the highest levels not really adequately describing. But the fact that theory is just generally giving us a perspective on what's going on, it doesn't mean that, like, if it's just broadly doing that, it doesn't mean that it's not causal. I mean, I think it has causal components to it. You're correct that, like, humans Like we delve into the very specific interactions of what's going on between these traits and why this is getting selected for. And we suddenly discover something very convoluted that isn't exactly described with the theory. Doesn't mean that the theory itself isn't valid in terms of its causal associations.
I'm hoping this question addresses you, and tell me if it doesn't. But here's where I kind of realized the argument, and at least a way of explaining it. Do you think let's say that you believe that's a theory of natural selection. Why do you not accept a theory of artificial selection?
It's the same thing. There's no difference
artificial
between
selection and natural selection are not the same.
There's no difference between them at all.
What's artificial
and
selection?
Sober pointed that out.
When minds select for.
It doesn't matter if minds select for it. Whatever selects for it is the selection pressure.
Yeah,
it doesn't matter what the selection pressure is.
Is there a theory of artificial selection? Yes or no?
Well, fuck yeah. There's a whole bunch of stuff on breeding.
No, I'm not asking if we can explain certain localities and certain breeders' intentions and what they want. I'm not asking for that. I'm asking for a theory.
We don't care about breeders' intentions at all. All we care about is that you select out the puppies that have long hair.
Is there a theory of breeders? Does that even make sense to you?
Yeah, it's called psychology, I think. I don't know. I'm not sure.
Okay. So give me the theory.
But that was a joke, Danny.
I mean, I guess there is a theory, like with dogs as an example. You could construct a theory as to why dogs over years their traits are artificially selected for, because breeders are having, like you were saying, have desires that say, I want long hair, I want black color, etc. We could construct a theory around that.
Okay, I think I
can give you something, Danny, that I haven't fully thought out. They selected foxes for docility. Okay, in Russia, a big experiment. And what they noticed is that the foxes all had rounded ears that were floppy. And they did not believe that they selected for rounded ears that were floppy. They selected for docility, right? And those two things were coextensive, basically.
Yeah.
So rounded ears that were floppy went with the docility. And I have no idea. I don't have any more information about why that was. It could be that they were inadvertently selecting for floppy ears and didn't realize it, right? Or it could be that docility and floppy ears are genetically related somehow. That they're. Are you aware of this, Jason? This Russian fox breeding experiment?
No, I'm not.
Okay, I'd have to look into it. But anyway, I think that would be a really good example for you to look into, Danny, and use.
Yeah, I'm trying to.
It's on YouTube.
I'm not saying when I ask, is there a theory of breeders? I'm not saying. What I'm not asking is, do we have explanations for why we see populations that are in control of breeders for the traits that they have? I'm not asking that question.
Right. Good.
Then what are you asking?
I'm asking for a theory.
A theory of what?
You see, because I don't take a scientific theory to be synonymous with particular explanations.
Yeah, I agree.
Okay, if you want a theory of natural selection, here it is. Okay, there is you have populations, right? So you have to have more than one. Within that population, you have copying, which means you have reproduction. Okay. Number two, there's mutation. So there's random, basically mutation or diversity in that population. So now we have a population. Let's start out with a completely homogeneous population, but we got to zoom ahead on 1,000 years. And now we have a diverse population with a bunch of differences, right? So we have a population that varies. Okay. Now we have reproduction. Okay. Overall, we have a selective filter of some sort. That selective filter is varying over time. Okay, we know that. We know the selective filter isn't going to be the same everywhere, right? All those things together are the theory of natural selection. You put those into a mathematical model, you write a computer program, and you can make predictions.
Yeah, this is... okay.
So what do you call...
Give up?
Do you still call it selection if it's epigenetics involved?
if there's, would you still call it selection if there's epigenetics involved? If the okay, I see where you're going, Top. So if the environment has an influence on those genes, it's going to be the same as if there was a mutation, except it's going to be a more directed effect because it's actually something from the environment is actually making a change in the genome for the next couple of generations. Epigenetics doesn't work except in fungi. It's the only place we found where it works for 100 generations or more. It usually disappears in about 3 or 4 generations. Methylation, that effect. So I don't know. Did I just confuse the issue? Go ahead, Todd.
Huh?
I
I
said
don't have
go
anything
ahead.
more. I don't have anything more. So
Oh, okay. Okay. I don't know. But wow. Danny gave up. Has Jason given up?
I didn't understand your response. Look, I guess, do you think that
Yeah.
causation is extensional or intentional? We'll start from the top.
Causation would be. I don't think that question makes any sense to me because
Okay, I take that to be a true dichotomy.
causation, as we know it, is possibly aleatoric, in that you cannot basically if you take a bow, the most perfect bow you can find, and you get a machine to draw the arrow back, right, to draw the string back, and you fire.
This is just not. Look, I'll just
Okay.
rephrase it.
Will you let me complete the example? Okay.
I know. Is it non-intentional or intentional? There's a true dichotomy.
Okay, if you draw the bow back and you hit the target and it hits the target at different points and every time, it's called aleatoric. That means that there's more than one causal effect happening, right? And
Sure. Okay. Is causation
there's no way.
intentional or
There's no, only in a perfect universe could you absolutely specify something that is going to hit the arrow in exactly the same way every time. There's always going to be a different. So causation is like multiple. You have multiple arrows.
Sure, I accept this. None of this is relevant to my question. Do you think that natural selection is intentional with an S or non-intentional with an S?
It doesn't. I believe it would.
It's a true dichotomy, Speedy.
I don't know. I don't
Okay,
think it's
well,
a
then
true
you don't know how
dichotomy.
to respond to Fodor's argument because you
I don't
can't
think
even
it's a
disagree
true
with it.
dichotomy.
You can't even disagree with the argument because you don't know.
I think the argument is bullshit.
How would you know if you don't even know if natural selection is intentional or not intentional? Because Fodor is claiming that
intentional refers to semantics when you change out basically one word for another, right? Intentional also refers to set theory. Okay, I don't see how this applies to natural.
Because look, every statement about a state of affairs will either be an intentional context or non-intentional context. And all that means is that when you take the nouns in the statement and you substitute it for other co-referring nouns, is it going to be true still in all cases, or will it not be true in all cases? Okay, so it's either going to be the case that it's going to be true in all cases, or not necessarily true in all cases. This is a true dichotomy. And if you don't know, you don't know whether even Fodor is wrong.
Okay, NS operates on the heart that pumps blood, not on the heart that makes a thump thump noise. Okay, that's a statement that somebody would say, right?
Sure.
And now you can reverse that, and we can say, "Oh, okay, this is like one of those intentional little bitches,
context.
Right?
It's an intentional context.
Right, intentional context. Okay, if you made those two statements, you would have to know a little bit about hearts pumping blood, and you'd have to know about thump thump
So you
noise.
agree that it's intentional with an S?
That statement is.
Okay, good. Then natural selection is intentional with an S. It operates intentionally. Okay.
It's entirely different.
Now
meaning.
I'm going to ask you: is causation intentional or extensional?
Okay, you cannot say that NS operates on the heart that pumps blood with absolute certainty. Because in a human population, I can tell you for a fucking fact that in mammals, the fact that the heart makes a thump thump noise has some small effect on fitness.
Look, so then you're saying is now natural selection extensional? Is that what you're saying now? Which one is it? Or do you have to go think about it before you? Because you should think about this because this is what voters originally said. And what I'm do is I try really hard to give you examples, analogies to get you to understand without using this language because the language is a little bit elusive. I grant it because you haven't thought about it.
I've thought a hell of a lot about it.
Well, then you would know.
The language makes
Either you
no
don't
fucking
know
sense.
that's
Okay,
intentional.
that particular dichotomy and that statement makes no sense whatever.
Do you think?
That is the problem? Let's try to make sense out of it.
Do you accept the law of excluded middle?
Oh, that's a good
Jesus
question.
Christ, Danny, don't go there.
Because it seems like you're not. It seems like you're an intuitionist.
This is where we're going to get. I'm
It's either
saying
A or
that
not
your sentence makes no sense given.
Does
the
A
theory
or
of
not A
natural
make sense to you?
selection.
Yes or no?
Okay. The theory of natural selection is not a sentence that says the heart may.
I'm not. Look, I'm just asking
Look
you.
what's on the screen here. Look what's on the screen here. It's
You're just
supposed
dodging. You're
to is
dodging.
articulate principles between ecological variables
You're
and certain
dodging.
phenotypic traits. No, it is not. This is wrong-headed from the beginning.
Okay, sure. Let me grant
That's what
it.
I'm trying to
Doesn't
get you
pertain
to
to my question.
understand.
I'll grant it. Doesn't pertain to my question.
Scientists lose their shit.
It does not pertain to my question. Let me just grant it. That everything on the screen is wrong. Who cares? I'm asking you a direct question.
What do you mean? Who cares? You said it. This is Fodor's argument.
Do you accept that the statement P or not P is true in all possible hypotheticals or worlds?
I'm not going to answer that, Danny.
Yeah, you see,
I'm
this
not-
is why
I'm not gonna
you're
play that game.
calling the argument bullshit when you don't even know the argument, given that you don't know that whether natural selection is intentional.
You're about
or
to get booted. You're about to get booted.
Well, then I'll
Okay.
shut up. I don't want to get
Okay.
booted, so I will.
No,
If
you
you're
wanna
going to
get
threaten
booted.
me, you're going to threaten me, I won't say anything more.
I don't know why like there has to be animosity on this topic because like actually, I mean, again, I'm just my own personal perspective. Like I kind of see what Danny is saying. It is a very interesting facet to think about. Like, is natural selection is not. There are some aspects that are not extensional. That like that are the issues of coextensive traits. Like I mean, I'm starting to kind of think about it a little differently. With regards to like what you're saying, the heart pumping the blood and the heart making the thump thump, like that there are these traits that are like ride along traits that aren't necessarily the selective pressures are not resulting.
They don't care
yeah,
about
they don't care about those. Yeah, but I do understand what Speed is saying is that it's a complicated system, and it may be that like that the thump thump. That there is some there may be some reasons why that trait has to be there for there to be for those to get selected because that's that trait has some importance, and that it's hard to disentangle them. But it is kind of an interesting thing to think about.
Yeah, Fodor wants to say you can disentangle them, but when you finally disentangle them, when the biologists do that, he said, "Hey, y'all did that on your own. You didn't utilize this theory."
So look at this statement here between ecological variables and certain phenotypic traits. Okay. We're complaining about the heart and the thump thump noise. What about the heart and the fact that the organism has to eat food? Okay. Those are coextensive traits, right?
Wait, what?
Does natural selection differentiate between those two things?
Does it differentiate between what?
Between organisms that have a heart and organisms that have to eat, because those are coextensive traits.
Well, there's
in,
some
all
organisms.
mammals.
Are there organisms that have hearts but they don't eat?
Yeah, and there are organisms that
They're
have
not
hearts that don't make thump noises.
So they're not coextensive.
Okay, there are organisms that have hearts that don't make thump noises.
No, all of them make noises, right? There's sound that comes from every single heart that makes noise.
No, I don't think so.
You're saying that there are no sound waves produced by the movement of a heart? No sound waves.
There are hearts that move, I think, I'd have to look at various arthropods and a few other things they basically have primitive hearts that move fluids around with muscles. There's no thump noise.
No.
Hey,
Are there noises, period? Are there noises, period?
But it's not a heart.
Can I ask something here?
Yeah, go ahead. David.
This whole, well, you know how you guys have always been talking about the thump and the pumping and the noise factor and all that. Like, let's say if you add to this argument that the thump noise is an emergent property from the pumping, right?
Sure.
So
That's fine.
so you have that, right? So you have that factor. So now if you take, now you're saying, does natural selection select for the pumping, or does it select for the thump noise? And in regards to that, couldn't natural selection pump, even though one is an emergent property from the other, couldn't it, natural selection could still actually select for one or the other? Or is
It could.
Yeah,
it
no,
just
that's fine.
coextensive,
Voters would be fine
right?
with saying that.
So
Look, there
how
are
does
going
that
to be cases in which making your heart making noises will actually kill you, or might even benefit you. Okay,
right,
Some
exactly.
noises might help you
Right.
know that might help a doctor know that your heart is okay. I don't know, right?
Right.
But that's just contesting the coextensional aspect of it. But what Fodor is saying that is if A and B are coextensional, right, and B seems obviously not conducive to fitness, then you're going to have a counterfactual. If you have A without B, there'd be a conducivity to fitness. But if you had B without A, right, let's say you had those noises or whatever frivolous spandrel or ride-along trait, their fitness would go blah. Okay.
And how do you know that?
Yeah, I don't. Yeah, how do you know it would go?
Well, that's what the biologists answer, right? And I think they do a good job of answering that. Hey, look, in these localities, these two traits go together. If you had that one trait that goes together with this other trait, if you didn't have that, we wouldn't see a difference in the phenotypic distribution apart from that trait and the most recent F generations.
The theory of natural selection is not supposed to articulate principles between ecological variables. And
Okay, Speed. Is it intentional or extensional?
That doesn't make any sense, Danny. I'm not.
Is it A or not A with respect to intentionality?
Okay, it makes no sense to talk about it.
Yeah, you're just trolling.
Okay, you're out of here, dude. Okay, I'm telling you that your statement makes no sense. I'm telling you that your statement makes no sense. We have to look at it again.
Look, do
okay,
you think
why is that? Okay, theory of gravity, is it extensional or intentional?
Intentional.
Okay, then theory of gravity?
Yes, laws and minds are intentional context.
Laws are intentional.
Yes.
Okay,
They're the Fodor says.
Give me two statements on gravity that make it intentional. Help me understand.
Well, okay, this is going to be a little bit difficult. I haven't done this in a while, but before I do, Fodor says there are two responses here. Either you invoke laws or you invoke minds. Okay, so he thinks that laws can account for intentional with an S causation. But given that there are no laws of selection, you can't appeal to that. Okay.
Give me an example of a law that accounts for.
Yeah, so if I say that, let me give you an example of a law of selection then. Okay. For every organism, for every ecological variable A, and you will have an organism with trait T. Okay. And so if T is coextensional with Z, okay, you're going to appeal to the law to say that given that law, it's T that is the trait of interest, given that for every ecological variable A, you'll have T and not Z.
Okay.
That's an intentional context, but it can be accounted for because you can appeal to the content of a law. Just like you can appeal to the content of a desire, you can appeal to the content of a law.
Okay. So
there's an example. So no, you might have thought for a second that laws are extensional. They are not.
Okay. Yeah, that's interesting. Okay, so you're calling that wait a minute. How is that intentional? I don't understand.
Because if you substitute the co-referring terms, it doesn't preserve truth value. Look, remember, ecological variable A, for every ecological variable A, you'll have an organism with trait T. Trait T and trait Z are coextensive. Okay, so then you're wondering, oh, I see this environment. I see trait T and it's coextensial with Z. Which one is matters, right? Oh, there's a law here. I see ecological variable A, so it's trait T and not Z that can that is the trait of interest, and that's what the law grounds that counterfactual. That if you only had trait Z, then you would have not had ecological variable A, okay, or something like that, or there would have been no conduciveness to fitness or whatever, okay.
Okay, so we have a law that connects A with T.
We have a law that goes with A and T. T is coextensive with Z, right? And the idea is that the law, when it flips, let's say a world in which ecological variable A, and instead of T, you get this referring term Z. Okay, it's not gonna be able to. There's gonna be a problem with fitness, right? And we know that because of the law. Because the law is saying something like, for every trait A, you have for every ecological variable A, you have a trait T, and where in a way where it's conducive to fitness.
Okay, so give me an example of an extensional theory.
Oh no, but you see, I think all theories, and if they're parasitic on laws, right? Now, remember, I'm not talking about the colloquial sense of theory. I'm talking about the scientific sense of theory, which is parasitic on laws. It relies on laws. It relies on regularity. But let me give you extensional causation, right? Suppose this: I strike a match and I put it on the floor and I burn the house down, and there's ashes all over the place. What's coextensive with the ashes is the fire. Okay. So fire and ashes go together in this context. Okay. So the match caused the fire, and fire is coextensive with the ashes. So if you flip them, does the match cause the ashes? Yes.
Okay, so the match causes
that's
both.
extensional because you flip you change between the coextensive traits. You go from match cause fire. Fire is extensional with smoke and ashes. You flip them. Does it preserve truth value? Yes. The match caused the smoke and the ashes. That's true. Because it grounds the counterfactual that had there been no match, there would have been no fucking smoke or ashes.
Okay, so
you need oxygen too.
How about dead bodies?
Sorry, what?
How about dead bodies?
What about them?
Sometimes there's dead bodies in fire. Sometimes there's not.
What are we saying explains the dead bodies?
Well, dead bodies are often coextensive with fires. Probably as often.
They're not. No, you can have dead bodies without fires. They're not truly coextensive.
Yeah, like as an example,
pump noise aren't either. So
you could have a fire, and there's a dead body in the house, but somebody could say they died of a heart attack. They didn't die of the fire, or they died because of poisoning, or they died because of old age, or they died. So you couldn't say the fire caused
the death
of the. Right. Yeah, I mean, you would have to investigate that.
You would have to stipulate that the fire and the dead body are coextensive. They're linked. So if that's to say every time there's fire, there's a dead body. If that's true, which it's not, then if something caused a fire, it would have also caused the dead body.
Yeah. So I mean, I guess intentional implies that there's a multitude of parameters that we can't, like, just like with natural selection. What you're essentially saying is that you can't tease out all of the potentialities. Therefore, you can't say that it is directly causal.
Let me take what you're saying, and you stop me if I'm characterizing wrong. With respect to a trait, there's going to be all sorts of coextensive properties with that. Okay. Right. So what's the thing about intentional causation is that you have an external cause that's picking out one of those one of those traits amongst the extensional set. Okay. And not the others. Okay. But the way that the only thing that could account for that are going to be, in terms of knowing that, it's going to be either laws or minds. Okay. But the way that causation works, if X causes an object, right? Or that's to say, what an object is, you can think of an object as, or maybe even a series of events. Let me just use object. Okay. This is just to get into my headspace. An object it's basically just a set of coextensive traits, right? What an apple is a red and a certain length. There's all these properties that are coextensive with each other. If the tree brought about the apple, it's going to bring about all those traits. Okay. And so the idea of a breeder, though, is that suppose they just wanted red apples. They didn't want all the rest of the stuff that came with apples, like the sweetness of it or something like that, then what you have to do is you're either going to have to appeal to a mind, which there is, or a law of selection, which there's not. It's a fascinating argument, but it's so unintuitive and horribly jargony. And so I don't blame people for not understanding it. I blame people when they say it's dumb and then can't give a response.
So how would you answer the question, is natural selection intentional or extensional?
Oh, you would say
I think it's
intentional. Yeah.
You'd say what?
It's intentional with an S.
Intentional with an S. Okay.
That's the problem.
But if gravity is intentional with an S,
Yeah. That means there's a law.
so natural selection, that means there's a law.
Remember, Fodor says it's okay to say natural selection is intentional with S so long as they're laws of selection, but they're not. So they can't appeal to it.
Okay, so you're saying that natural selection should tell you which phenotypic traits connect with which ecological variables.
Well, it should tell you that.
It's what you said. This is what you said. I'm just,
Yeah,
it's
that's
like,
fine. I'm fine with that.
Okay. So that's what you think natural selection is supposed to do. It's supposed to tell you if, what the hell? Okay, if you have blue skies, it's supposed to tell you that there should be frogs with green eyes.
Sorry, say that again.
If there are blue skies, if there's a world with blue skies, there should be frogs with green eyes.
Are you saying those are coextensive? Are you stipulating that they're coextensive?
No, I'm asking you if natural selection is supposed to tell you that. Okay, if there is a theory of natural selection,
okay,
then natural selection is supposed to tell you that for a given environment with blue skies, there should be frogs with green eyes.
Yeah, it's going to tell you whether I'm confused. So you're saying there's an ecological variable, sky being blue, and then there's a phenotypic trait,
frogs with green eyes.
The frogs with green eyes. A theory of evolution is supposed to tell you whether there's a connection there.
Whether there's a connection there. Okay, it's supposed to tell you there's supposed to be some law that connects blue skies with frogs having green eyes.
Or that the idea is that if there's a valid theory, it's going to tell you whether that there is whether you can say that blue skies interact causally with organisms like frogs that have green eyes, right? And so if you have a good theory or a good explanation, it should either rule that out or affirm it.
Okay. So it should tell you whether or not in an environment with
I'm not going to say natural selection per se. I'm going to say any theory of evolution is supposed to articulate, any mechanism of evolution at least, is going to articulate such an interaction, whether there is an interaction and there's not.
Okay. So we should be able to go to our textbooks, look up our theory, figure out the theory, and now we can get our paper out and we can go from blue skies to frogs with green eyes.
Yeah, I think nothing in the literature, whether that be laws or these generalizations or models, would tell us that there's a connection there. So we don't need to think about it.
I'm not sure what you just said, but I'm still hung up on whether or not we should. Okay, so now we should be able to go to our same theory and see that for red skies, there should be frogs with black eyes.
Are
So
you understanding him, Jason?
all of the cases connecting every ecological variable to every phenotypic trait.
Well, sometimes there isn't an interaction. Isn't.
What?
Sometimes there's no interaction, right? We do like I'm going to say, I'm right there with you. There are good models of selection. There are good patterns of selection that we've derived from being in the fields, of being in the ecologies and knowing the organisms. And it's totally valid to appeal to that, to know whether the blue skies affect eye color, right? And it might be that our models and our patterns don't suggest that there is such an interaction.
Okay. I'm just not saying the import. There cannot be a theory that connects every ecological variable with every phenotypic trait. In fact, we don't even have a good theory of how to A mereological
You're using
theory.
theory as
How that-
explanation. I think you're
okay,
equivocating on the
why are
word
you talking over me?
because you're misunderstanding.
We don't even have a good theory.
You don't care that you are.
We don't have a good theory that defines what traits are. Like, for instance, the heart that makes a thump thump noise, right? That can be considered one trait. We can divide that as one trait. If we have a gene A that's linked to gene B, we can consider that one basically locus. That's one locus. We can look for that in a population. It doesn't matter if they're linked or not. If we don't have any other information to separate them, then we have to assume that they are a singular trait. If you look at a population of all animals and every single animal that has a heart that pumps fluid around the body makes a thump thump noise, which is not the case, then we basically would consider that one trait. Why would we not consider that one trait?
You could. I mean, Jason, are you understanding the objection?
Okay, we could separate hearts out. We could say hearts are, they have a particular cell type. They have four chambers. They have, or we could say a heart is anything that has any one or more chambers. Okay, you can define traits any way you want. And the theory of natural selection handles singular traits, basically. Normally gene sequences, that string of characters, and we look at how it varies in populations, and there are there are laws that we can apply that can tell you how that population will evolve over time.
Yeah,
And
I think you're
model that
equivocating
with
on
computer
law.
program. What's that?
I think you might be equivocating on the law and theory. If you're
Yeah, okay, you're gonna get into the law thing, basically. Yeah, I would call it theory, not law. I don't like the idea of laws.
Well, then there's
Laws
no
laws are regularities. Okay, we see the law in the regularity. I don't believe in.
Well, laws are just facts.
Yeah.
Well, no. Look.
Theories
it's
are
a fact that we're
law.
talking. Jason,
The regularities, right, Jason?
It's a fact that we're talking right now. That's not a law.
Well, but I mean that this is like the standard definitions. Like a theory is explaining why something is happening. Like when we say the law of gravity, the law of gravity is the law of gravity. It doesn't explain why something is occurring. It is describing a state.
Yeah.
So,
look, there's a lot of disagreement in the literature here. This is the typical what the high schooler I taught this way of differentiating. But if you think about it, laws are an explanatory resource. Let me give you why. Let's just take Newton's second law of motion, right? If I know that, first of all, they're going to explain non-causally. Okay.
Sure.
Okay. So there's explanatory. Now, what Fodor is saying is that natural selection, if it's a cause, you got the existential intentional problem. If it's explanatory but non-causal, then you've got a different problem. You got the problem that the content doesn't get you to the answer, right? And so the idea is that laws of gravity or Newton's laws of motion, what you can still say that if the acceleration is 3 meters per second squared and it's a 5 kilogram object, then you can explain why, right? That has a force of 15 newtons, right? But it's not like what caused the object to go at 15 or to have a force of 15 newtons is that law, right? But nonetheless, it's predictive and it's explanatory in a different sense.
Yeah, I agree with that.
Okay.
I mean, as you guys were talking about this, I just kept thinking of like, if we were able to quantify all the interactions and all the effects, that we would be able to tease out the causal relationships, correct?
Yeah, Fodor's going to say yes. Yeah, Fodor's going to say, because remember, Fodor says we can give good. Now, interesting. There was a forum in which Fodor was speaking, and someone asked him, well, there are laws of alleles, and there are laws of what do you call it? Of certain ecological variables like temperature and humidity and all this stuff. But he's saying that those laws are not biological laws. They're going to be either chemical or physical laws of physics. And so the whole point is that natural selection if you're going to count it as a law or a theory, which you might not, that's going to be of biology. So it's true that like this is governed by laws, but there are no laws of tape. Right, just like so, there are laws that govern the causal interactions of DNA, but those are going to be chemical or laws of physics. So, if you understood all the physical facts, you would understand what was going to happen in the system, but you're going to inevitably feel the more fundamental laws, not biological laws of. And actually, what's really interesting is that Fodor is actually giving. He said, actually, it might be even possible that they're biological laws, but there are just none right now discovered. And if there are biological laws, they're going to be very complicated placeholders, right? Placeholders are like mass, acceleration, and force. So Newton's laws of motion are F equals ma. F, M, and A are placeholders. But there are so many placeholders in an ecological environment. You have to account for alleles, temperature, proteins. I don't like all sorts of. There's so many placeholders, and so what a law of biology is going to look like, and evolution is going to be this very, very extensive.
But it's possible.
Yeah, but he says it's possible.
Yeah, so that would imply that there is a cause to, like, we could know whether this heart is being selected for the pumping or the thumping.
Oh, he already grants that.
That's possible.
But he's saying that somehow we still know how to disentangle co-extensive traits apart from appealing to laws, right? And he's saying that's perfectly valid. But the thing is that the source of that knowledge does not come from natural selection. It comes from knowing the very deep particulars about the ecology in question as well as the organism.
Yeah, I mean, I guess you could say we have this overarching theory of natural selection, but if I incorporated all of these other external facets of differing laws and understandings of our world that support that, like, we talk about like differential reproduction and the effects of the environment, I could be, like you were saying, I could say, I know all the facets of the environment and I know all the interrelationships of that to differential reproduction. Therefore, I should be able to get down to all the specifics and then say, this interaction of all these effects, or this is causing this to occur without human involvement.
Right. I think
that's possible.
I think Fodor is just going to say that, okay, that's fine. But I think that fundamentally you're going to be appealing to non-biological laws.
Okay. Yeah, I would agree with that. I mean,
hey, boys and girls, we got to end this.
Okay.
My coffee ran out in my brain. It quit. Yeah, we're at 2 hours and 23 minutes. So anyway,
let me just say one thing, and that's, I'm not commenting anymore. I am starting to understand Danny's point on this. So I appreciate him explaining it over and over again. It has given me more insight into this and has made me think more specifically about these aspects of intentional and extensional with regards to natural selection. So I appreciate that.
Yeah, and I've thought more about it. I've thought more about it than I ever thought I would. And
it's good.
But the point is like completely useless, moot. Other than making us okay, just shut up for a minute, Danny. Other than I'm summarizing, and then we're going to end this stream. Basically, it has other than making us think more carefully about our theories and separate our theories into little groupings and classes. It's basically the reason why Fodor got shouted down so badly by scientists, and the reason that Danny causes scientists to lose their shit, is that overall what they're recommending, their final statement that evolution should just be natural history, is bullshit, and they can't support it.
Yeah, you can't support. You don't even know whether natural selection is intentional or extensional. So you don't. How could you say it's bullshit when you don't even have a position?
Because it's just like totally.
Do you have a position on intentional and extensional about causation, natural selection? Do you?
Totally meaningless.
So you're not even interacting with the argument.